In a nutshell, dimensional analysis. Dimensional analysis is a method of converting one unit into another. At first it might seem really complex, but it is in fact not so hard and virtually foolproof. It all comes down to fractions. When you were taught how to multiply fractions, you were probably taught this shortcut. 2/3 times 1/2. You cancel out the 2's, and your answer will be 1/3. Or another example is 2/3 times 3, which because it's a whole number, we put it over 1. The 3's cancel, and you get 2. In dimensional analysis, you look at conversions just like fractions. For instance, if you have 14 inches, and you want to know how many feet you have, first you need to know what's the relationship between feet and inches. If you don't know, you should look it up. When you do that, you'll find that 1 foot equals 12 inches. Then we set up our fraction. 14 inches over 1, because it's a whole number, times another fraction. The way you want to have the fraction set up is so that the inches will cancel. So we put 12 in the denominator and 1 foot in the numerator. Our labels cancel, and then we get that 14 inches equals 1.16 repeating feet. Because this is a calculation using measurements, we need to look at the significant figures. 14 has 2, so our answer must also have 2. Look at the 1 and the other 1. This 6 rounds the 1 up, so our final answer is 1.2 feet. Now the question is, does this make sense? Does it make sense that 14 inches is a little bit more than 1 foot? If the answer is yes, which it is, then you're done. Dimensional analysis also works with the metric system. Let's say you have a piece of wood that's 157 centimeters long, and you want to know how many meters that is. First step is to look up the conversion factor. When you do that, you find that 100 centimeters is equal to 1 meter. So we set up our fraction. 157 centimeters is a whole number, so it's over 1. We multiply that by a fraction, where centimeters will cancel. So 100 centimeters goes in the denominator, and 1 meter goes in the numerator. When you do this calculation, the centimeters cancel out, and you get 1.57 meters. The original measurement has 3 significant figures, and our answer has 3 significant figures, so there's no need to round. The final step is to see if that makes sense. Does 1.57 meters is at about 157 centimeters? Does it make sense? The answer is yes. So we're pretty sure then that that is the correct answer. You can also convert between the metric and the English system. So let's take our 1.57 meters of wood and see how many feet that is. First step, once again, to look up the conversion factor. 1 meter equals 3.281 feet. We set up our fraction. 1.57 meters over 1, because it's a whole number. Multiply that by a fraction where the meters will cancel. So 1 meter is in the denominator. 3.281 feet is in the numerator. The meters cancel. When we do our calculation, we get 5.15117 feet. Our original measurement has 3 significant figures, so our final answer should also have 3. So that means 5.15. This 1 is less than 5, so it doesn't change that 5. Our final answer is 5.15 feet. The last step, does that make sense? And the answer is yes. Let's say we wanted to do something more complex. time, for instance. You have a measurement of 123,000 seconds, and you wanted to know how many days that is. Well, I don't know what the conversion factor is from seconds to days off the top of my head, but I do know this, that 60 seconds equals 1 minute, 60 minutes equals an hour, and 24 hours equals a day. Because I know this, I can use 3 conversion factors instead of just 1. I start off like this, 123,000 seconds, just like I would normally. That goes over 1 because it's a whole number. I multiply that by my first conversion factor. We want to change seconds into minutes. Seconds is in the numerator here, so it must be in the denominator here. 1 minute goes in the numerator. Second conversion factor. 1 minute's in the numerator, so 60 minutes must be in the denominator, and 1 hour in the numerator. Last one. Hours is in the numerator, so hours must be in the denominator, with a day in the numerator. We go through and we cancel now. Seconds cancels, minutes cancels, hours cancel, and we're left with days. When we do this calculation, we get 1.42631 days. Our original number had 3 significant figures, so our answer must also have 3 significant figures, 1.42. But the 6 is above 5, so it rounds this up to 3. 1.43 days. Because this number is significantly less than this number, it makes sense that that is the correct answer. There's just one more type of problem left, and that kind of problem has derived units. And a derived unit is actually made out of 2 or more different measurements. In this case, speed. For instance, meters per second is a derived unit, and so is miles per hour. They're actually made out of 2 different units, one for distance and one for time. When you're working with derived units, sometimes you need to convert both. So let's say we have 132.1 centimeters per second. And we want to know how many miles per hour that is. We have 2 conversions here, centimeters into miles and seconds into hours. From the last thing that we did, we already know that 60 seconds equals 1 minute and 60 minutes equals 1 hour. Now let's look at the distance conversions. Centimeters goes into meters. 100 centimeters equals 1 meter. 1,000 meters equals a kilometer. And 1.609 kilometers equals 1 mile. When we start off, we're going to start off pretty much the same way, but with one slight twist. Notice up here that this is actually already a fraction, with centimeters in the numerator and seconds in the denominator. This is often people's mistake. They'll put seconds in the numerator when it in fact should be in the denominator. If we start with our distance conversions, centimeters to meters, 100 centimeters in the denominator, 1 meter in the numerator. 1,000 meters in the denominator, 1 kilometer in the numerator. 1.609 kilometers in the denominator, 1 mile in the numerator. Next on to time. But wait, if we put 60 seconds down in the denominator like we did before, it won't cancel. We must put 60 seconds in the numerator so that it will cancel the seconds in the denominator. And the same thing here. We need to put 60 minutes in the numerator and 1 hour and the denominator. When we go through, we cancel our centimeters, we cancel our meters, we cancel our kilometers, and we are left with miles for a distance measurement, which is what we're looking for. With the time, we cancel our seconds, we cancel our minutes, and we're left with hours, which is what we're looking for. When we do this calculation, we get 2.955624 miles per hour. Our original number has 4 significant figures, so our answer must also have 4. 2955. This 6 being above 5 rounds the 5 up, 2.956 miles per hour. Or how we often see it in the United States, 2.956 mph. And that's dimensional analysis in a nutshell.